Today's honors geometry lesson is on section 6.4, special right triangles. The objectives are to determine the lengths of two sides of a 45-45-90 and 30-60-90 triangle when the length of the third side is known. In a 45-45-90 triangle, the hypotenuse is root 2 times as long as a leg. So if we put this into an equation, we know that in a 45-45-90 triangle, the hypotenuse will always be root 2 times as large as the leg. In a 45-45-90 triangle, the legs will have the same measure. So if we look at the diagram here, we know that one leg is 12, which means this leg down here is 12. So if we want to find x, which is the hypotenuse, we can go ahead and use our equation. So now we can say that the hypotenuse is going to equal root 2 times the leg, which is 12. So the hypotenuse of this 45-45-90 triangle will equal 12 root 2. We can use the same equation to work backwards when we're given the hypotenuse. So remember that equation from before. In a 45-45-90 triangle, the hypotenuse will always be root 2 times the leg. So in this case, we have the hypotenuse, which is 8, and we're going to call each leg x. So if we fill in our information, the hypotenuse, which is 8, is going to equal root 2 times the leg, which we're going to call x. So if we solve for x, we can divide both sides by root 2, which leaves us with x is going to equal 8 over root 2. We always want to make sure that we simplify, meaning that there are no radicals in the denominator. So since root 2 is already simplified, I can simply go ahead and multiply both the numerator and the denominator by root 2. And if we multiply, we're going to have 8 root 2 in the numerator. In the denominator, we're going to have root 2 times root 2, which is root 4, and we know the square root of 4 is 2. And then if we simplify our fraction, we have 8 root 2 over 2, which simplifies into 4 root 2. So now we know that each leg is going to be equal to 4 root 2. In a 30-60-90 triangle, the hypotenuse is 2 times as long as the shorter leg, and the longer leg is root 3 times as long as the shorter leg. So if we set up two simple equations based on this theorem, so we know that the hypotenuse in a 30-60-90 triangle will always be 2 times the length of the shorter leg. And then we also know that the longer leg will always be root 3 times the length of the shorter leg. So no matter what information we're given, whether we're given the hypotenuse, the shorter leg, or the longer leg in a 30-60-90 triangle, we can use one of the two equations in order to find the missing sides. So let's go ahead and look at the diagram that we're given. So we're given 6, which represents the short side, or the shorter leg. We're given x, which represents the hypotenuse. And we're given y, which is going to represent the longer leg. So based on the information we're given the shorter leg. So we're going to use the first equation here to find the hypotenuse. So if we know the hypotenuse is x, we can say the hypotenuse is going to equal 2 times the shorter leg, which is 6. So the hypotenuse for this triangle is 12. Now we can use this equation here to find the longer leg, which they're going to refer to as y. So using our equation, the longer leg, which is y, is going to equal root 3 times the shorter leg, which is 6. So we know that the longer leg in this 30-60-90 triangle is going to equal 6 root 3. Using the same equations, we can go ahead and find the missing sides when we're not given the shorter side. So in this case, we're given the longer side, and we're going to work backwards to find the shorter side. and then use the equation that we know in relationship to the hypotenuse and shorter side to find the length of the hypotenuse. So from the previous slide, we know that the hypotenuse will always equal 2 times the shorter leg, and that the longer leg will always equal root 3 times the shorter leg. So for the first example, we're going to work backwards from the longer leg to find the shorter leg. So we're going to use this equation here. So we know the longer leg is equal to 8. We have root 3 times the shorter leg, which they're going to call x. So in this case, to get x by itself, we can divide both sides by root 3, which leaves us with x is going to equal 8 over root 3. So again, we need to make sure we do not have a radical in the denominator. So we can multiply both the numerator and the denominator by root 3, which is going to leave us with 8 root 3. And then root 3 times root 3 is root 9, and the square root of 9 is 3. And since 8/3 is simplified, we now know that the shorter leg is going to equal 8 root 3 over 3. So now we can use the hypotenuse equation of 2 times shorter leg to find the value for y. So if we go ahead and find y, which we know is the hypotenuse, that's going to equal 2 times the shorter leg, which we found to be 8 root 3 over 3. Okay, so remember when you multiply fractions, you're going to take your whole number and turn it into a fraction by putting a 1 over it. And then we can multiply straight across. So 2 times 8 root 3 is 16 root 3, and 1 times 3 is 3. Since 16/3 is simplified, we now know that the hypotenuse is equal to 16 root 3 over 3. Let's go ahead and take a look at one more example. So let's find the perimeter of triangle ABC. Triangle ABC is made up of two smaller triangles, one triangle which is a 30, 60, 90, and a second triangle which is a 45, 45, 90. So we're going to focus on the 30, 60, 90 triangle now because we're given the hypotenuse. So remember the relationship in a 30, 60, 90 says that the hypotenuse will equal 2 times the shorter leg. Okay. In this case, we're going to refer to the shorter leg, which is opposite the 30, as x. So the hypotenuse of the triangle with the 30, 60, 90 is 12. So if we put 12 in for the hypotenuse equals 2 times x, and divide both sides by 2, we now know that the shorter leg is going to equal 6. Now we can use this information to find the longer leg, which we're going to refer to as y. So remember in a 30, 60, 90, the relationship between the longer leg and the shorter leg says that the longer leg, so the longer leg is going to be equal to root 3 times the shorter leg. So if we call the longer leg y, we're going to set that equal to root 3 times the shorter leg, which we just found to be 6. So now we know that the longer leg in this 30, 60, 90 triangle is going to be equal to 6 root 3. Now let's focus on the right-hand side of the triangle, which makes a 45, 45, 90 triangle. So remember in a 45, 45, 90 triangle, the legs are going to be equal. So if this length here is 45, 6. If this length here is 6, it means that this length here is also going to be 6. And remember that the relationship in a 45, 45, 90 triangle says that the hypotenuse will always be root 2 times the shorter leg, which is 6. So now we know that the hypotenuse is going to be equal to 6 root 2. Okay. So now if you take a look at the triangle ABC, we now have a value for all three sides. So the last step is to actually find the perimeter. So to find the perimeter, we're going to take side AB plus side BC plus side AC, and that's going to give us our perimeter. So we know the length of AB is 12. The length of BC is 6 root 2. And the length of AC is made up of these two distances. So 6 root 3 plus 6. So when you are adding radicals, it's just like adding variables. They have to have the same number underneath the radical. So in this case, there's only one thing I can simplify. So I can take 12 plus 6, so 12 plus 6, make that equal 18. And since 6 root 2 and 6 root 3 have different radicals, I cannot simplify them because they will have different values. So we can say that the perimeter of triangle ABC is going to be equal to 18 plus 6 root 2 plus 6 root 3. This is the end of the video. If you have any questions, watch the video for a second time. And if you still have questions, write down any clarification questions that you may have and bring them to the next class.